Hey guys, we're starting chapter 5 today. So it'll be chapter 5, section 1. We're going to talk about the basics of triangles. Today, a lot of terms, 2 new theorems. It'll get harder as we go, but you need to know these words for today. We're going to name triangles by their side lengths, meaning the lengths of the sides. We are going to have 3 different types of triangles today for the lengths. We'll classify them by their lengths. The first one will be 2 sides equal. And that is called isosceles. Oh my goodness. There you go. Isosceles triangle. 2 sides equal. We'll mark them like this to say the 2 sides are equal. Okay. Then we're going to do a scalene. Scalene triangle. And I always go scary scalene. No sides equal length. Okay, so no sides are equal. That's scalene. Okay, so I'm not going to mark it. When no marks are on there, that means no sides equal. And then if all 3 are equal, we call it equilateral. This means equal, and lateral means sides. Okay, equal sides. All 3 sides equal length. So I'll mark it. Okay. So we've got isosceles, scalene, equilateral. Now we're going to talk about triangles by their angles. So if I have a right angle, it's called a right triangle. It has one 90-degree, which is right, 90-degree angle. Okay, that's a right triangle. If I have an acute triangle, that means all 3 angles are less than 90. All 3 are less than 90. Okay? Acute, all 3 angles are acute. If you guys forget that, let's write that over here. Acute angle. The measure, is less than 90 degrees. That's an acute triangle. Okay? So acute triangle, all 3 angles are acute, less than 90 degrees. Okay, that's acute. And then if I do obtuse triangle, this would be obtuse. Right? This is obtuse angle. It's more than 90 degrees, less than 180. One angle more than 90 degrees, and that's obtuse angle. Okay? And then the last one would be if all 3 angles are equal to each other. But that has to be marked, okay? If all 3 angles are equal to each other, it has to be marked, otherwise you don't know that. Just like it might look like a right angle, but the mark has to be there to tell you it's a right angle. Or you have to be told it's perpendicular. Same thing here, you have to be told they're equal. So this is called equiangular. Equal angles. See it in the words? Equal angles. Okay, all three angles are equal to each other. Okay, so you've got a right triangle, you've got acute, you've got obtuse triangle, and you've got equiangular triangle. Okay, now when we talk about a triangle, we are always talking about the inside angles. Okay, that's how we talk about it. Okay, all triangles have three interior angles. Right? You have an angle at each vertex. I'm going to say an interior angle at each vertex of the triangle. And I'm not going to say, when I say triangle ABC, okay, when I do this, and if I say angle A, always assume I'm talking about an interior angle, the angle that opens to the inside. Okay, that's why it's called. This angle opens up to the inside of the triangle. Okay? And usually we are talking about interior angles. Now this part's a huge deal. This triangle sum theorem. This is big. Big deal. Okay? We will use this all year. All year. This is big. Okay? When you add all the interior angles together for any triangle, it's always 180 degrees. Always. It's a golden rule of triangles. So when I do this, the interior angles, measure of angle A plus measure of angle B plus measure of angle C, always equals 180 degrees. Always. That's important. Okay. So we're going to do the sum. Sum means to add, right? Of the measures of the interior angles of a triangle equals 180 degrees. Okay, we're going to do practice with all these. Okay, now this one's kind of weird. It would be good if you have your pencil and you do what I do on this one. So I'm going to grab my pencil, okay? I'm going to draw a triangle like this. Triangle. I'm going to lay it out so it looks kind of the same. Okay. Now, if I take my pencil and I extend just one side, okay, just one side. I've got in this case, I have an obtuse angle right here. I'm going to call this angle 1. Do you see that? Okay, that is an exterior angle of the triangle. That's an exterior angle. It is adjacent to the interior. Angle 1 and angle 2 are adjacent. Okay, here's angle 2. This is angle 2. This is angle 1. They are adjacent, which means they share a vertex and they share one side, but they don't overlap. They don't share any of their interior points. They share a vertex and a side, okay? This is angles 1 and 2 are adjacent angles. Angle 2 is interior, angle 1 is exterior. Now, I could, watch what I'm doing, please. first time I just did this, I extended this side here. And I said this was my exterior angle. This time I'm going to go ahead and extend this side. Okay, if I do that, okay, this would be my exterior angle going this way. This would be my exterior. And still, this is my adjacent interior angle. If you had both of them, you can see these are vertical angles. So these angles are congruent to each other. It doesn't matter which side you extend, but only extend one side at each vertex. Okay? We don't want two at each vertex, just one. So I'll leave it this way. Okay? So I've got an exterior angle here. There's my interior. I'm going to extend this side here. Here's my exterior angle, right? Got an exterior angle. And then I can do this one. It really doesn't matter which side you extend. And this is my exterior angle. Okay? So you have one exterior angle at each vertex. Right? It is formed by extending a side, or made. How about made? Do you guys like made better? Made, M-A-D-E, by extending one side of the triangle. And it is adjacent to an interior angle. That means it shares a vertex and a side. Or a ray. Okay. So in this picture here, you can see there's one vertex, one exterior angle here. You've got one one exterior angle here and one exterior angle here. So there's 3 exterior angles to every triangle. Okay, now this is the part that's the theorem that we'll do some math on. Okay, this angle is an exterior angle, right, in your picture, and it's formed by extending one side. A and B are interior. Oh, I'm sorry. Okay. Angle 1 is an exterior angle. It's formed by extending one side. And then A, B, and C are interior angles. This angle here is adjacent to angle 1. This angle B is not adjacent to angle 1 because they do not share a vertex. They kind of share the side. But angle B and C are not adjacent. They're not next to each other. They don't share a vertex. Angle A, this interior angle, is also not adjacent to angle 1. It does not share the vertex. So this is what the exterior angle theorem says. Okay? The measure of an exterior angle of a triangle equals the sum, remember sum means to add, of the 2 non-adjacent interior angles. Okay? I'll do a little highlight, see if that helps. Here's angle 1, right here. There's angle 1. I got it orange one. Here's yellow. Okay. If I use angle A is not adjacent to angle 1. Oh, that looks not good, right? Let's try orange. Okay. Angle A is not adjacent to angle 1. Angle B is not adjacent to angle 1. Now C is adjacent, so we're not talking about C. So we're going, the measure of this exterior angle, in this picture it's measure of angle 1, equals the measure of the two remote interiors. So measure of angle 1 equals measure of angle A plus measure of angle B. And that's it. That's all we got. I'm going to go over the back with you and do, in class I'm going to assign this, but I'll do it here also. Okay? Now it says classify the triangle by the sides, the side lengths, and by the angles. Okay? So on number 1, sides. Okay, I'm going to flip it over. When I talk about sides, I've got isosceles, which is 2 sides. It's really 2 or more sides, but we usually just do 2. Scalene, no sides equal. Equilateral, all 3 sides are equal. Okay? So in this picture, I've got 2 sides. So this is, you guys write it out. Okay? I hope you wrote isosceles. And then by the angles, you've got the symbol. So its angle name is, flip it over and look. You should put right. So you call this a right isosceles triangle. Now in this one, oh, you guys, yeah, we did. Okay. In this one, the side name is equilateral, right? All 3 sides equal. And the angle name is, you could say, some kids are saying acute. And we're going to learn later, if all 3 sides are equal, the angles are equal, but we haven't learned that yet. This one here, no sides are marked equal. So this is, whoa, scary scalene. Perfect for Halloween. This is scalene, AKA scary scalene. Okay? And you have an obtuse angle. And if you're not sure, you could always take like a piece of paper and stick it in there. Look, that's more than 90. It doesn't tell me how much it is. I'll do it with something better. Here, let me grab one of these passes. Here, this orange pass. If you put the orange pass in there, you can see that orange pass is 90 degrees. So this has to be more than 90, right? So that's an obtuse angle. So this is a scalene obtuse angle. Triangle, I'm sorry. Scalene obtuse. Okay, over here, no sides are marked, no angles are marked, but they're all, unless it's marked 90, and I can put that, this here, these are all less than 90, so I'm going to say scalene acute. Okay, now, this is telling me degree. This is the measure of this angle. It's 78 degrees. This angle is 31. This is the name of the angle. So this problem here, I know that they always add the golden rule 180 degrees. So measure of angle 1 plus 78 plus 31 equals 180. Add these together. When they're on the same side of the equal sign, you just add them together. So measure of angle 1 plus, this is 109, equals 180. Now you're subtracting. Opposite of addition is subtraction. And so you're going to get measure of angle 1 equals 71. Okay, you guys try those. It's the same logic. Okay, the only thing tricky here, like, you have to remember that that means 90 degrees, right? So when you do this one, it's going to be measure of angle 1 plus 90 plus 38. Some of you guys might go, well, if this is 90, the golden rule is 180. That means these two acute angles have to total 90 also. And that's fine. But I can go measure of angle 1 plus 90 plus 38 equals 180. And then you guys solve it. Okay? This in here, what? I've got 60, 60 in angle 1. Measure of angle 1 plus 60 equals 180. This one I've got measure of angle 1 plus 40 plus 30 equals 180. So you guys finish those, okay? Now we're going to do a little, this one's harder. This angle that I'm going to highlight in orange is formed by taking one side and extending it. So this is an exterior angle. Okay? And then my two, well, there's three interiors, right? This would be one. That's an interior angle. Interior, interior. I am not talking about this one because this angle is adjacent to the orange angle, to the exterior angle. So I'm not talking about that one. I'm talking about this angle and this angle. Those are the non-adjacent interior angles. If you flip the paper over, you're going to see the measure of the exterior angle equals non-adjacent, measure of the non-adjacent angle plus the measure of the non-adjacent angle. So the measure of this angle, now these are ugly because they're not numbers, right? 4x minus 18 equals 2x plus 6 plus 36. I suggest that you guys stop, make sure that you can solve this, and then turn it back on to check your work, okay? I'm going to keep going though. So I'm going to add like terms on the same side of the equation. This gives me 2x plus 42. I want all my x's on one side of the equation. It's usually easier to get rid of the fewer number, the smaller number. 4 x's take away 2 x's is 2 x's. Subtract 18, positive 42. Now I have to get rid of this 18. I want the x by itself. So I have to do inverse of subtract 18 is to add 18. I add 18 to both sides of the equal sign. I've got 2x equals 60. Inverse of multiply by 2 is divide by 2. And I get x equals 30. Now this one says solve for x and then find the measure of each angle. So I'm going to take this 30 and I'm going to finish the problem. Okay, look in here. Okay. So this 30 is going to go right here where x is. Okay, 30 has to replace the x. So I'm going to write the 30 right over it. Now remember, this is multiply. Okay? So this exterior angle is 4 times 30 minus 18. Go ahead and multiply that out. And you guys can stop, right? And then you do it. This 30 also goes in here. So where the x is, I'm going to get rid of the x. Instead of 2 times x, it's 2 times 30 plus 6. So I got 2 times 30 plus 6. Again, stop it anytime, right? 66. And this angle is 36. Let's check. We just said the exterior angle equals the sum of the two non-adjacent interior. So is that true? 66 plus 36 is 102. 102 equals 102. Yep, we did our work, right? Okay. This one's a little harder. We've got all interior angles this time. That's all we're doing. No exterior angles. We're not. This one, I had an angle facing outward of the triangle formed with one side of the triangle and by extending one side. And we're going outside the triangle. Exterior, interior, interior. Different formula. This time they're all three interior, so we're using the triangle golden rule, which was the sum of the measures of the interior angles is 180. I'm going to write 90 here. I'm going to go ahead and add these up. So I've got 2x plus 3x plus 5 plus 90 equals 180. Some of you guys might go, oh, that's 90, so that means just the sum of those two is 90. You could do it that way. Okay, I'm going to add like terms. 2 x's and 3 more x's gives me 5x. Add like terms. Okay, I'm done adding like terms. So now I have to do opposite operations. When I do opposite operations, I do it to opposite sides. So I'm going to subtract 95. Now, opposite, inverse operation of multiply by 5 is divide by 5. And I've got x equals 17. Again, I have to find the measure of each angle. So this one here, the 17, is going to go right in here. So I've got 2 times 17, right, 34. This one, I've got 17. So it's going to be 3 times 17 plus 5. $51 plus 5, which is 56. Let's check and see if we did good math. This one's 90. According to the golden rule, all 3 of these should add for a total of 180. 6 and 4, 10, 9, 10, 180. Woohoo! You did a good job. Okay? Okay, last problem. This one's hard. I suggest you guys look at it a little bit. You start with what you know, and you just work out. And I can see in this one that I've got a 90-degree angle and a 40-degree. So the first thing I would do is find measure of angle. I'm going to do it with pencil so I can erase it. Measure of angle 1, right here. Here's angle 1. I've got my triangle, right? I know the sum of the measures of the angles of a triangle. Golden rule is 180. So that means 90 plus 40 degrees plus measure of angle 1 is 180. So find angle 1 first. That's what I would do. Okay. Measure of angle 1 is 50. I'm going to erase all this mess here. Okay. Now, if I want to connect this over here, right? If you guys remember this, vertical angles. I had a teacher, remember, tell me this. V for vertical, angles. Vertical angles. Okay, vertical angles. Vertical angles are always congruent, which means their measures are equal. So we said the measure of angle 1 is 50. So that means the opposite of that, the vertical angle, angle 3 is 50. Okay, you guys try, see what you could do.